Let's look at a question now related to a redox reaction, which means that different substances are being oxidized and reduced. And so specifically in this question, we're going to look at the reaction between iodine, I2, and K2S2O3 solid as it forms K2S4O6 solid and potassium iodide. And what we want to do is figure out the different changes in the charges or the oxidation states for each of these compounds, as well as who the oxidizing and reducing agents are. Okay, and so to help us out, let's use the periodic table first. Okay, so if you look at the periodic table, we can figure out oxidation numbers, typical oxidation numbers, based on the positions of the different elements in the periodic table. So as you've seen before, group 1 tends to be +1, group 2 is +2, skip the middle part, and then group 3 is +3, 4, 5, 6, 7, 8 as far as valence electrons. But in terms of charges, this can become plus or minus 4. Then this tends to become -3, -2, -1, and 0 for the noble gases. Okay, so now that we know that, let's figure out what the different oxidation states are for these things. So if I look at K2S2O3, the oxygen is going to be -2, and the potassium is going to be +1. It means that the sulfur I have to figure out. So I have -6 from all the oxygens and +2 from the 2 potassiums. That adds up to -4. That means that this has to be +4, so that it adds up to 0 overall. So each individual sulfur is going to have to be +2, so I have 2 of those. And then if I look at the iodine, this one's a little tricky. You might think at first that it's going to be -1 because I have this rule that the halogens tend to be -1. But because this is iodine by itself, it's neutral. So this is going to have 0 as the oxidation state or the charge. So this is going to be 0. And then if I look at the products, K2S4O6 and potassium iodide. So once again, potassium is +1, oxygen is -2, so this is still +2. This is now going to be -12 because I have 6 of them. So this is going to add up to -10, which means that this is going to have to add up to +10. So since I have 4 of them, each of these is going to be 2.5. Now if I look at the potassium iodide, this is going to be +1 for potassium, -1 for iodine. So now let's look at who changed, right? The sulfur changed because sulfur went from +2 to a fraction, which is strange, but still possible and allowed. And since it basically went up in oxidation number, this is getting oxidized. Remember, oxidation is a loss of electrons, so the oxidation number tends to go up. Now, if you look at the iodine started out at 0 and then went down to -1. That means that this got reduced. Remember, reduction is a gain of electrons. So now in terms of oxidizing and reducing agents, these are the things that cause things to get oxidized or reduced. Okay, and so it's a little tricky. Oxidizing agents cause oxidation. That means that they themselves are getting reduced. Reducing agents cause a reduction, so they themselves are getting oxidized. Okay, and the oxidizing agent and reducing agent always show up on the left-hand side or the reactant side of the reaction. So now if I look at what's happening to the iodine, for example, the iodine is getting reduced. That means that I2 must be the oxidizing agent because it is causing the oxidation, which means that K2S2O3 must be the reducing agent, which is causing the I2 to get reduced. Okay. Notice that when I specify a reducing agent or an oxidizing agent, it's not just the one substance in that compound that is getting individually oxidized or reduced, but I refer to the entire compound as the agent, whether it's a reducing agent or an oxidizing agent.